Every day, the opposition to the use of genetically modified organisms, or GMOs, gains more and more traction as advocates call for their respective state or country to implement food labeling laws and ban GMO crops. And that mounting pressure seems to be working. Just last July, Monsanto, the leading GMO manufacturer, withdrew its application to sell genetically modified seeds in the European Union. However, while GMOs have begun to lose their luster, other chemical companies are using Monsanto's bad press as an opportunity to open up the market to another questionable technique. It's called mutagenesis, and it's nothing new. In fact, it's been around for years. But even though it's been an agricultural mainstay, it's a process that has by and large remained unregulated. So what do we know about mutagenesis, and is it the next generation agribusiness? To talk about all that and more, I'm joined by James Shapiro, a professor of microbiology at the University of Chicago. James, thank you for joining me.
Well, it's a pleasure.
First of all, mutagenesis is a complex process to understand. Can you talk a little bit about how it works and how it really differs from the way GMOs are modified?
Well, let me see if I can make this clear. Mutation, which is acquiring genetic changes, is a natural process. All organisms can actively modify their DNA, and they do so, especially when they're under stress. That's a key to evolution. Mutagenesis is treating organisms in a way that increases the number or frequency of mutations, such as treatment with chemicals or radiation. But there are also natural processes like hybridizing different species or infection with viruses and bacterial pathogens that are mutagenic as well.
Sure.
Now, GMOs are different in that they're understood to be organisms which have extra DNA from unrelated species inserted into their genomes by laboratory genetic engineering. This is true of the Monsanto products you were talking about, Roundup Ready and Bt toxin plants have bacterial DNA inserted into them. But GMOs also occur in nature because we've learned that organisms exchange DNA. This is called horizontal transfer to distinguish it from vertical transfer from the parents. And I think the big mistake is to think that GMOs can only arise in the laboratory. They also arise in nature, and they're essential to evolution.
Well, I think you did a good job of making that or distinguishing rather the difference between what's natural and what's sort of altered purposefully. But just to be clear, what kinds of crops have breeders been developing by using this technique?
Well, they've developed all kinds of crops. I mean, the pesticide-resistant varieties. Mutagenesis has long been used in plant breeding to get changes in the life cycle and sun tolerance, yields, and so forth. Mutagenesis is just a staple of agricultural genetics.
And there have been many studies out there about the effects of GMOs on human health. What do we know at this point about the impact mutagenesis can have?
Well, we would only know that from testing. And in most cases, mutations will be harmless. However, even the most natural genetic changes can produce harmful pests. So we need to avoid breeding plants that stimulate the emergence of pests, like superweeds or Bt-resistant insects that have caused problems with the existing GMOs. I just wanted to make the point that those GMOs can even transfer their DNA to wild organisms and create a strong selective environment for very resistant pests.
Right. So going off that, I wanted to talk a little bit about how mutagenesis is sort of affecting other plants. And can you just talk a little bit about that and how it might impact the future of farming?
Well, I think if we use the single resistance model, which has been what's been done with GMOs, that's not a good way of going about it. Those plants have taken over the seed markets, and they contribute to the problems of monoculture, where we have to put in lots of chemical inputs. So they're not very helpful in the long run.
And as we know, GMOs are now facing a lot of scrutiny around the world, and that means more of the market will be opened up to chemical companies like BASF and DuPont, who manufacture seeds using mutagenesis. These seeds also happen to be cheaper to produce. How do you see these mutagenesis seeds really sort of fitting into the market going forward?
Well, as I said, if they're based on single traits, it's going to create a problem. And it's going to contribute to increasing monoculture and loss of what's called germplasm variability that we have in the plants in nature. It also develops a very chemical-dependent kind of agriculture.
And not only are they cheaper, but they are by and large unregulated at this point. Of course, it may be difficult to regulate them. You know, chemical companies say there's no need for regulation because there haven't been any major safety issues so far. What do you make of that argument? Can they be regulated?
Well, I think there have been issues with super weeds and pesticide-resistant weeds and Bt toxin-resistant insects. We need to have more information about that. So we need to do more investigation. And I think that the best thing is that the FDA should develop the expertise and the facilities it needs to test new crop varieties, whatever methods are used to generate them. I don't think being GMO is in and of itself a bad thing, but what characteristics are we going to introduce? There is work on plants that can grow where plants, agricultural products don't grow now. They can grow in dry or salty environments. That may prove to be very positive. But where the GMOs contribute to chemical-dependent monoculture, that's a negative development, and I think that's something that we should avoid. As for safety issues, every new food source should be tested and verified that it's okay.
Sure. It is a process a lot of people don't know much about, so I appreciate you coming on and breaking it down for us. James Shapiro, professor of microbiology at the University of Chicago. Thank you.
It's been a pleasure.